Hello everyone, welcome back to Let's Unbound. In this video, we are diving into FRQ 6 from the 2024 AP Calculus AB exam. This is a beautiful mix of area between curves, solid volumes, and rotation around a horizontal line. If you have ever struggled to set up volume integrals or visualize regions from graphs, this one is for you. Let's break it down step by step. Here is a question. Yes, it's no calculator, and here we go. Two graphs are given, f of x and g of x. The area under f of x from 0 to 2 is marked as r, and like area under between f of x and g of x. Then area under g of x is marked as s. So three questions are given. So first is R be the region and S be the region given. We have to write but do not evaluate an integral expression for R. Then let S be the region bounded by the graph G and x-axis. Region S is the base of the solid. So we're going to make a solid from this, base being S. For this solid, at each x, the cross-section perpendicular to the x-axis is rectangle with height equal to half its base in region S. Find the volume of the solid. Okay, the description of solid is given. We need to find the volume. And we need to show a complete work here. Third one, write but do not evaluate an integral expression that gives the volume of the solid generated when region S, as described in part B, is rotated about the horizontal line y equal to 10. Okay, so two volume, different categories. So this is a must-know concept for your AP journey. So let's get started solving one by one, and here we go for the first one. Very simple. The function f and g is defined by this. R is the region bounded by the graphs f and g from 0 to 2. Write but do not evaluate integral expression for area of the region R. So area is accumulation of like between two functions. So it's you have to find upper like which is upper, which is lower. So area will be this area expression bounded between two curves, integral a to b, modulus of, use modulus upper minus lower. Okay. So now area would be, we are doing it from 0 to 2. Upper function is y equal to f of x. It's clearly it's above and g of x is below. It's that simple here. So modulus f of x minus g of x. We don't want to evaluate dx. So integral 0 to 2. So when this modulus will actually will help us means when we are involving ln function, absolute like those kind of function, it will be helpful. So now f of x is x square plus 2. Then minus g of x is x square minus 2x. Minus g of x is what? Minus x square plus 2x. So minus g of x is minus x square plus 2x whole dx. And you just evaluate it. Not evaluating, we are simplifying. 0 to 2, x square cancel. It's 2 plus 2x dx. So area is, you can take 2 common, 0 to 2, x plus 1 dx. This is the most simplified expression, right? That's simple for part A. Now moving to part B, let S be the region bounded by the graph G and the x-axis from 2 to 5. So yes, 2 to 5 between the graph G and the x-axis, the shaded region is yes. Region S is going to be base of the solid. Okay, for example, how the cylinder is base for, circle is base for the cylinder. In same way, in our solid, this is going to be, actually not like this. So this is going to be the base. This shape, 2D shape is going to be the base. And then if you keep on adding this, for example, like how we form a cylinder. So cylinder, circle, same circle, we will keep on adding. Okay, so if I keep on adding, for example, you can think about a coin. If you keep placing a coin over and over again, it will not be a circle anymore. It will be a cylinder. Okay. So that's the logic behind this. So if I make like thousands and infinite number, like millions of things over here, actually it will have some height. I will be placing lots of things and I will get a circle. Same way, but we have this structure. Okay, so this structure, I will put it the same structure, like you copy paste and everything, you put stack it on one or the other, you will get a solid. Right? So now, for this solid, at each x, the cross-section of perpendicular to the x-axis is, yeah. So basically, the volume is depend upon cross-section. And it's not like a usual easy shape. So we are dealing with the splitting into rectangles. So rectangle with height equal to half of its base region in S. So base region, and also they give about a height of the rectangle that we are splitting. So each X we are going to make the rectangle, and that rectangle is perpendicular to X-axis. So we are going to make rectangles like this. Okay, and rectangles with height equal to half of the region. So rectangle's height will be half its base region in S. Find the volume of the solid. Show the works that lead to your answer. Okay, I hope the concept is behind this is clear. Let's start working on. What is my base? Is S. So your base is G of X. And height is half of its base region in S. So like if you're making a height of a rectangle here, half of G of X. G of X means half of G of X. Okay, this is going to be your base. So height is 1 by 2 G of X. That's it. Now area of rectangle, many rectangles will be there. So area of rectangle, general thing is base into, base into height. So G of X times half G of X, which is half G of X square. Now area is accumulating, okay, so we need to find the volume of the solid. So this is area. Volume is accumulating the area, integrating area. So let's go volume, and it's only from 2 to 5. And what's your area? Half G of X squared. This area will be changing if you change X, okay? Because at X here, it's different rectangle. But here, it will be a very big rectangle. So that will change. And dx. Okay, here we need to evaluate, find the volume. So we need to continue proceeding this. Okay, so let's simplify. Volume equal to, I think it will be good here. Okay, so volume equals, let me take half outside, 2 to 5. What is G of X? It's well defined and given here at the very first. X square minus 2x dx. Very simple integration here. Just apply the power rule. Let's simplify it first. And it's whole square, right? G of X the whole square. So this will be 1 over 2, 2 to 5. When you expand this, we are using this formula. A plus b whole square will go a square plus 2ab plus b square. But I have minus, so change the minus for middle stuff. Right? So this will be x squaring the first term of the binomial x power 4 minus 2 times a is x square, b is 2x plus b square is 2x the whole square, so 4x square dx. So 1 over 2, 2 to 5, x power 4 dx, then minus 2 outside, 2 to 5. Okay, not 4 outside. 2 and 2, it's 4. So let's take the common 4 and x cube dx. Again, from this, take 4 outside, 2 to 5, x square dx. Moving on. So we got 1 over 2 equal to, integrating x power 4 will be x power 5 by 5. 2 to 5 minus 4, x power 4, right? Power root 2 to 5 plus 4, x power 3 over 3, 2 to 5. Okay, so this 1 over 2, let it be out and let's apply. 5 power 5 by 5 minus 2 power 5 by 5. Then minus 4 into 5 power 4 by 4 minus 2 power 4 by 4 plus 4, 5 power 3 by 3 minus 2 power 3 by 3. Okay, yes, without calculator, we need to make it to single number. 5 power 5 is actually 5 power 4. 2 power 5 is 32 by 5. Let's take this 4 inside, negative 4. So negative 4 and 4 will get cancelled. Negative 5 power 4. And negative 4 into this. Here also 4 and 4 will cancel. So plus 2 power 4. Then take 4 inside. 4 by 3 into 5 cube. And 4 inside minus 2 cube is 8. 8 times 4 is 32 over 3. Okay, now 5 power 4. This will get cancelled. And I need some space. Here we go. So 1 over 2, negative 32 over 5 plus 2 power 4 is 16. And plus this will be 5 cube is 125. 125 and 2 it's 500. 125 times 4 by 3 minus 32 over 3. Simplifying further. So this will go 1 over 2, 500 over 3. And okay, I think we need to check. So negative 32 over 5, negative 32 over 3, plus 16. Okay, if we simplify, like you can cross multiply, negative 96 minus this will be 160. And here I should multiply with 15. So 16 times 15, it's going to be 160 and 32, 192. Wait. Yeah, 16 times 15 is going to be 15 times 4 times 4. 240 actually, it's sorry. So 240 and simplifying all this 240 minus 60, it's minus, sorry, plus 80, 96. Okay, simplifying all this, we got negative 16. And over 15 is there. Okay, I make the common denominator. So negative 16 over 15. And I'm going to make the same denominator multiplying by 5. So this will go half. 2 500 minus 16 over 15. So half 2 500 minus 16 is 2 490. So 2484 by 15. And you can multiply them 2484 by 30. And you can start simplifying. Let's divide it by 6. You will get 414 by 5. So this is our final volume. Volume of the solid is 414 by 5 cubic units. That's simple it is. Right? So with this, let's move to C. And write but do not evaluate an integral expression that gives the volume of solid generated when region S, as described in part B, is rotated about the horizontal line. So when we are rotating like this one, wait, we are rotating this S. Okay, so let's take this image. We are rotating. When you're rotating, you will get a volume about y equal to 20. So this is the line y equal to 20. We are going to rotate about this line, this region S. Okay, right. So now we will use washer method about a horizontal line. So in washer, we need outer radius and inner radius. So applying washer method, outer radius is, this is your outer radius about the line. So y is equal to 20 to y equal to 0. This to x-axis. So from here to x-axis, this is the outer radius, which is 20 units. Y equals to 0, sorry, 20 to x-axis. That is y equal to 0. Now calculating inner radius. Inner radius is y equal to 20. We are rotating about this. So again, you go there to your to your g of x. Okay. So from here, you're not going to take the x-axis to your base area S. So how will you calculate this? This will be, this complete thing is 20. We are rejecting the g of x. So it's 20 minus g of x. So y equal to 20 to your curve g of x. And this is the thing. Full thing is 20. You cut off this, you will get this radius. So outer and inner. And washer area is pi into inner outer radius square minus inner. So outer radius is 20 square minus inner radius is 20 minus g of x the whole square. Right? Now going for, okay, right, but do not evaluate. Such a easy thing for us. So volume for washer method is volume will be pi into, that was this pi I took common outside, integral we are doing for this region, right? So 2 to 5. 2 to 5, and you simplify this part, 400 minus 20 minus, g of x is defined, right? So we can use it. It's in the very first starting description, x square minus 2x, right? So minus g of x means minus x square. So you can do, let me put x square minus 2x, the whole square. So use the brackets carefully and correctly. Okay, we might use this in next calculation. So whatever you do here, do it with utmost care. Okay, don't mess up with brackets. It will completely change your answer. So that's it, right? But do not evaluate for the given description. Yes, hope this might be easy, understandable. So that's it, only 3 parts here. So thanks for watching. I hope this video might be helpful for you. If yes, do like, share, and subscribe. And yes, with this, the playlist also come to an end. AP Calculus AB 2024. All the FRQs have been covered. So thank you for your support. We will be updating for BC also very soon. Until then, keep learning and keep practicing with us. See you in the next video.